us would call a neuroergonomics approach, so using physiological sensors to understand what's going on in the brain, kind of a thing. And so we've been looking at that in a number of areas. I'll just highlight a couple. One has been, one of our recent ones, and Stephen Chong in the audience has been involved in this work, sponsored by Toyota, has been looking at, okay, so if relatively novice users of these systems are exposed to these systems for the first time, what's that going to do to their attentional or mental workload, their attentional load or mental workload? And so we bring them into the lab, we have them use adaptive cruise control, use active lane keeping, experience some of these systems for a period of time, and then encounter a couple of events. Some that if they understand how the systems work, they would predict that it would work, you know, what was about to happen. Like you're following a vehicle and it slows down. You've got adaptive cruise control on and it slows down because you've entered a construction zone and the traffic ahead of you is slowing down. So your vehicle will automatically slow down too, and then it will speed back up to the preset speed once you get out of that zone. If you understand that adaptive cruise control works that way, that's not a big surprise. It can be a surprise and increase attentional load or workload if you don't understand that. Other things like sudden cut-in events. If a car suddenly cuts in front of you, your adaptive cruise control won't automatically pick that up immediately. It takes a little bit. So you need to be aware of that and interact yourself. At the same time, we've been using, and I'll explain this task just briefly, an auditory oddball task. It's commonly used in laboratory research, and it's kind of an artificial task, but it turns out that it allows us to get a nice, robust indicator of attentional load or mental workload. And basically, the idea is that you wouldn't even have to respond, but in many cases, we ask them to respond, but they're hearing this series of beeps, like beep, 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 beep. Turns out that beep, we have this automatic brain response to that, whether we want to or not. And there's a positive wave deflection in our ongoing electrical activity that we can measure from the scalp of the brain about 300 milliseconds after the onset of that. And it turns out that that's a really robust metric of mental workload or attentional load. If we're doing nothing else but listening to that task, we see this big wave deflection. Okay, so we've got lots of attentional energy and our brain processes that automatically. But if we're engaged much more intently in some other kind of a task, that we still have that response, but it's diminished. Okay, so it turns out that in lots of studies, that gives us a pretty robust metric of mental workload. So we had people doing that task while they're interacting with these systems to get a sense of how much attentional load are they having to put in to utilize these systems. And then we gave a bunch of knowledge and trust surveys before and after that I won't have time to talk about. But basically, highlight of some of the results, we find this kind of interesting. Not surprisingly, performance on the oddball task, so we did ask them to respond, was worse when they were driving or engaged with the automated systems and driving relative to when they were just doing the task by itself. That's not surprising. That's what we would expect. But you can see that diminished P300 response in red there relative to the one over here on the left, indicating that, yep, they have less spare attentional capacity when they're doing that, okay? More interestingly is the next one, when they were engaged in both active cruise control and active lane keeping, we saw another reduction in that P300. So you would think that, okay, now they're actually doing less because they have two systems. They're not having to steer or maintain their speed, but we actually see that their sensitivity, their performance went down when they're doing less, and so did their P300 response, suggesting that they don't understand the system, so they're actually it's more attentionally demanding to try to understand and use more automation in this case than less automation. So bottom line, from some of this work, we know that automation doesn't always make things easier, particularly if drivers are inexperienced. One thing we'd like to know, we don't know yet, is how long it's going to take for people to get comfortable enough with these systems so that we'd see that, that workload go back down, if you will. So there's more work needed for that. And also, I mean, there's some research to suggest that people can understand some of the limitations of the automation and they can be aware of that. But if they don't experience it for a period of time, they sort of forget. And this is a frightening thing. I mean, in some of the scenarios that we designed ourselves in the lab, I found myself doing that. If I was engaged with active cruise control and I'm following a car for a period of time, it stops at stop signs, stoplights. So does my car, right? That happens a number of times. The next time I'm approaching a stoplight, there's not a car in front of me. I'm thinking I'm going to stop. And I'm like, oh, no, wait a minute. It won't stop. I have to stop. And that's in a simulation that I helped design myself. And I can forget that. And I've heard anecdotal stories of other people. So that changing our behavior is going to be an important issue. Okay, so just quickly, I want to talk about a couple of other things we've done. So I'm pretty convinced that now with the increasing ability to be able to get physiological metrics of driver state, whether that's heart rate. We're even getting EEG systems now that are very low cost that you can wear. They're lighter weight than a pair of sunglasses. You can forget that you have them on, and they're becoming increasingly robust. Ford's got some that are implanted in the seat to get heart rate, not EEG. But anyway, in position sensors, that we're going to be able to get a lot more indication of what's going on with the driver by using these. So one of the things, and this was work sponsored by NHTSA, was looking at, could we detect mind wandering? So periods of time when the driver's eyes are on the road, but his or her mind is not on the road. So they're having that endogenous attentional lapse, if you will. And we did a series of these studies. I'll just highlight some of the main results. Bottom line is yes. If you want some of the details, I'm happy to talk about it, but we also have published papers in this area. So with EEG, we could tell with this P300 response that I was just talking about, we could tell when drivers, you might not be able to tell with the naked eye because they're looking at the road, but they're staring out at the road. So gaze concentration, another thing that's already can be picked up with low-cost cameras that are already installed in many vehicles. That could robustly tell whether or not people were actively engaged or not. And then heart rate as well, and heart rate variability. So we were able to do that, sorry about that, with manual driving. So then we began to look at, could we do that, could we use these sensors with partial automation? And in particular, then taking it another step further, can we not just detect it, but can we detect it ahead of time to know whether or not somebody's more likely to miss some signal from the automation? Okay, like that perhaps had become less reliable. So we had a relatively low fidelity simulation for this, but it was an automatic lane changing task. And if you're not familiar with this, manually you'd get an arrow that would say, change lanes, so you'd change to the next lane, you'd go right. You get another arrow that says go back left, you'd go back left. Okay, so we're using this task, only it's automated. So the driver's monitoring this, but they're not having to actually do it. So they're not having to maintain their speed. It's like a level 2 system. Okay, but they get these little cues in addition to which direction they should say that they should go, or the automation is going to go, telling them whether or not the automation is particularly reliable. So as that little arrow gets more red, that means the automation may make a mistake. Okay, so it's become less reliable. Maybe it started to rain or snow, or the sensors are getting dusty, or for some reason it's not as confident that it's going to be able to do the right thing. So we asked people to detect this, and we had them go through 5 different drives, about 11 minutes each, and they would try to detect this arrow, and then the automation still, most of the time, the arrows were relatively infrequent, about only 20% of the time, and most of the time the automation still did the correct maneuver, but occasionally it did nothing, and then occasionally it did the wrong thing. okay, which would be particularly dangerous. And they were asked then to monitor that to be able to tell whether or not that was what was going on. So again, our primary goal was, could we tell within a second or two prior to this cue whether or not people would even notice it, whether or not they would notice it, or take longer to respond. And it turns out, again, just a real highlight summary of the results, that many of the same metrics that we'd found for the mind wandering were also sensitive to your ability to detect this task, or this cue of the automation unreliability. So heart rate variability was predictive. Our EEG was also predictive, but heart rate variability was predictive, but not on its own. It added to the predictive capability, and same with gaze concentration. It added to the predictive capability, but wasn't sufficient. But the EEG was highly significantly able to predict this. So bottom line, we may be able to, in the near future, successfully detect when people have lost vigilance. But that's not, we can't stop there, because it may be impossible or irresponsible to expect people to maintain sustained attention all the time. We can't just give them an alarm every time we say, oh, you're mind wandering, beep, come back, come back. Not only would that be totally annoying, but it would probably just fatigue them completely. I mean, we naturally are going to go in and out of these different states. So we need to find more new and creative ways to bring them back effectively when they're needed, but maybe let them mind wander, let them engage in other activities as long as they're somewhat aware. At least that's my viewpoint. That's nobody else's funder's statement on that, but that's my viewpoint. I don't think it's even possible or responsible necessarily to make them pay attention all the time. So in summary, in semi-automated vehicles, drivers are expected to stay in the loop. I'm not sure they understand that. We need to help them understand that. And we need to help them do this to the extent, because they're not good at it by themselves. And we'll probably have to use a number of different strategies, providing cues and monitoring their physiological state and helping them re-engage in a more effective way than we're currently doing right now in order to improve safety. Want to thank the many hardworking people. A lot of this work was done at George Mason University, where I just recently came from, but we're picking it up here at Wichita State now and running full speed ahead. And thank you for your attention.
Thank you, Carol. So much great information this morning. I can't wait to see what they're going to come up with to help keep people engaged and help keep people's minds from wandering. That is going to be very interesting. Okay, moving on this morning, our next speaker is Ray Nee. And Nee is Associate Professor of Human Factors Program with the Department of Psychology at Wichita State University. Dr. Nee's research focuses on understanding the perceptual and cognitive processing of dynamic 3D visual information and performing complex tasks and everyday activities such as driving, and how cognitive training procedures and advanced technologies could help improve performance of these complex tasks. Recently, his work has focused on improving driving-related visual functions, driving performance, and preventing falls among older adults, as well as examining how human drivers, especially older adults, interact with autonomous vehicles in order to improve driving safety. Please welcome Dr. Ray Nee.
Thank you, everyone, for coming, and I really appreciate David and Carol for their introduction of the mental model and from human factors perspective. And today I'm going to talk about how the human drivers are going to or needed to study how they interact with autonomous vehicles from a little different perspective. So first, let's talk about a few numbers. We know the numbers do not lie, and many of us should have learned about there are more than 40,000 5,000 fatalities every year, 3 years in a row. And you might wonder what that means. That means every day, just in average, there are more than 100 people died from traffic accidents. And you might still, it's nationwide. What does it tell us, for example, like the Wichita area? And can you make a guess how many accidents there are over last 10 years or on a yearly basis in Wichita area? We get data from Wichita Police Department about the traffic accidents record. Over last 10 years, there were more than 45,000 accidents reported, and there probably are more unreported accidents just in Wichita. And of course, we know it costs a lot of time and resource lost. And this is a simplified model of how human drivers interact with the environment and interact with the vehicle. So basically, the human drivers perceive information from the environment and then respond to those events and apply the action and control of the vehicle, and then the vehicle's status change is reflected in the environment. So it's a closed loop. This is how the human drivers control the vehicle and to maneuver and to drive safely from point A to point B. And given the prevalence of the traffic accidents and from the analysis, 94% of the traffic accidents have been attributed to human errors. And this is a more complicated model, a more complete model, how human drivers interact with the environment and with the vehicle. As you can see from the left to the right, there are different stages how we process visual information and how we make a response and how we project what could happen in the next 1 second, 5 seconds, or 1 minute. And then we apply the action to control the vehicle so that we can safely drive and maneuver. And at each stage, our human drivers, our brain could make error, could make a mistake. So it's a chain reaction. Usually it's not because of one single factor that causes an accident to occur. So, well, this is the information processing model that was proposed by Ansley in the 1990s. On the other hand, so the emerging technology of either advanced driving assistance system or the automated vehicle, the purpose of those technology is to help the driver to drive more safely. So with the assisting system, I would call it assisting system because the level, either level 2 or level 3, they still need human drivers' input. So in hope to help driver to drive safely, the assisting system will take input from the environment and then apply its understanding of the environment to control the vehicle. So now we have one additional component in this loop. Okay? And the thing is, how well, as Carol and David already explained, how well we understand this system operates. And in turn out, we don't have a good understanding of how the artificial intelligence or the automated vehicle system work. And to give you an example, I taught my wife to drive when we came to the US, and which, well, turned out to not be a very smart choice. And on the first day, that was back when we were in California, and we hit the road. I took her out to the, it's a local drive, but the speed limit in California is higher than here in Kansas. It's, if I remember correctly, it is 50 miles per hour. So she took the steering wheel and drive along, and then there's an exit. We need to make a right turn. And she did not check the blind spot. And a car behind us swooped and honked really hard. it's not uncommon in California, so you'll hear the honk a lot. So I guess it is because I didn't understand her mental model. Because men are from Mars and women, ladies are from Venus or whatever planet. So, and now that was almost 20 years ago, and now I'm going to experience again. I need to teach another lady in my house, my teenage old daughter, to drive. That worries me a lot. So if we think about the traffic accident numbers, and what we see is if we plot the number of accidents or fatalities as a function of age, what you will see is U-shaped function. So on this end is the younger teenage drivers. On this end is older drivers. So now I have to worry about two things. One is my teenage old daughter, and I'm getting older. I start to worry about myself on this end. And thankfully for the introduction of the automated system, there seems to be really a good hope in 20 years when or 30 years when I get retired. But based on people's knowledge about automation, and if we plot again, if we draw a line about people's understanding and the trust in automation, especially autonomous vehicle, starting from 0 to 100, using that point scale, we measure people's trust and understanding of automation. I'm probably on the lower end. I'm a little more conservative as compared to some other people. So in my understanding is, well, the automation is great invention, has a great potential, very promising, but the technology is not there. The title for this forum is called Technology Takes the Wheel. I hope it won't happen in the near future. Yeah, I hope it will take longer and more efforts from all the community, including manufacturers and researchers, to do a very thorough and systematic investigation research before the technology really takes over the wheel. And the reasons are going to be covered in today's presentation. And yeah, one of the famous entrepreneur claimed, if the human drivers can use our eyes to see the world, to observe the road and operate the car, the cameras should be able to do that. No. If you are experienced in taking digital pictures, you realize when we take pictures using either our cell phone or digital camera, the camera does not operate really well under low light conditions or in shades. And imagine that's the only first stage of the information processing for the automated vehicle, because that is in the optics system. And what about the brain behind the camera? Our brain has been evolved over millions of years. And how long does the artificial intelligence exist? It might take, I'm not saying it's going to take another 1 million years for the artificial intelligence to evolve, but it's going to be longer than people expect. So let's take a look at some of the, again, so I call it AI factors in accidents or in automation. So basically, in each stage that our human drivers experience when we process the information in the environment and apply control to the vehicle, the artificial intelligence are going to experience the same thing. And they are prone to the errors that our human operators experience. So here is some numbers. So in 2016, human drivers drove over 3 trillion miles. In contrast, the automated vehicle have driven in total only 20 million miles until today. And if we look at the numbers, again, the fatality per 100 million miles driven by the human drivers is only 1.18. So contrary to the general beliefs or some myth, our human drivers are pretty safe. Our brain has evolved in such a long way. It's very accurate. It's a very good system. And if you take a look at the right column, you realize, okay, over the last 3 years, ever since the Tesla 3 hit the road, there are in total 6 fatalities. And as we just talked about, there are 20 million miles driven in total. You can do a simple calculation. So again, we can say the sample is not big enough for us to draw any meaningful conclusion. But we can certainly say there's not enough evidence indicating the current automated vehicle is safer than human drivers. We cannot make that claim. Again, it is very promising technology, but we are far from being there. Okay, and again, Carol and David have shared some of the images, and I'm not going to repeat it. But again, it has a lot to do with how our mental model, how our understanding of the automation works. And from my perspective, and based on my training and experience, what I want to focus is on the environmental factors that could affect driving safety for both human-controlled vehicle or for the autonomous vehicles. And the LiDAR system currently utilized in many automated vehicle technology other than Tesla, because Tesla is solely based on the cameras. So those automated vehicles could resolve 2 centimeter size from a distance of 300 meters or even further. And our human operators, human drivers, can do well as well. So if you think about 300 meters away, and we can resolve without any problem, 9 centimeters wide, it's like this size. And how many times do you really need to resolve that much detail while you are driving? We know for the pedestrians, our head is more than 20 centimeters wide, right? And our body, shoulder to shoulder, is even wider, right? From different angle. So we don't really need to resolve that much detail to be a safe driver. And when driving at night, you can see almost half of the accidents occurred at night in low visibility conditions. And we know the glare, the rain, and the snow put a lot of more threats to the human drivers. But at the same time, the current automated vehicle technology, they are also prone to those inclement weather conditions or driving under low visibility conditions. There's no evidence showing the autonomous vehicle technology is superior to human drivers nowadays. There's simply no evidence supporting that claim. And again, for the other human factors related at level 2 or level 3, the vehicles need human drivers' input. They require us to keep an eye on the road. So in other words, aging, fatigue, drowsiness, distraction, inattention, all of those human factors that have been linked to accidents or human errors, they also apply to the current automated vehicle technology. Make sense? So the current technology, at least from what I can see, maybe within the next 2 decades or even 3 decades, again, I'm not very optimistic about when level 4 or level 5 technology will finally become reality. So at the same time, we want to let people know the technology that currently available will not help us to solve these issues, let alone when we talk about vigilance, when we talk about mental model. Learning to use the the limitations of the technology. It will take a lot of time and efforts to do that. So when we think back about this loop, control loop, now we have the technology behind the wheel, and many people will let the automation system to control the car. Now we are not steering, we're not pressing the gas and the gas pedal and the brake pedal. So the human drivers are removed from the closed control loop. At the same time, we are required to focus on the road. You are not controlling while you are trying to focus. How hard that would be. That's one of the major research research project in our lab. And when we talk about this in the lab, we had a very intense discussion in the lab. And one of my PhD students said, well, when you are not engaged in such a task, many of our cognitive resources are released, right? You're supposed to get a better sense of the environment so that you can respond faster. I said, well, probably no. If you are not, yeah, just like Carol said, if you are not required to respond and when it's needed, how could you react fast enough? Because we don't know when the technology could fail. And the technology itself doesn't know when it will fail. In other words, it will now inform you, all right, this is time for you to react, to take over the steering wheel. But even when it happens, do you think the human drivers will have enough knowledge about the situation? In other words, their situation awareness has declined. And it takes time for us to get, again, immersed in the environment, to know well enough and to project what's going to happen. Make sense? So that's a huge question. That's why I put a question mark. We lost control of the vehicle, and we do not know well enough about the assisting system. So in order to study this, most of the current driving simulation systems were developed more than 10 years ago. So in order to study this, we developed our own driving simulation software, thanks to an NIH-funded project. That we want to test under semi-automation, different levels of automation, how well people can really detect the roadway hazards while they are not engaged in driving or controlling the vehicle. So this is an example of the driving simulation simulator we designed and built in our lab. In the long run, what do we want to do? Not only to do the research in the driving simulator, but also we want to incorporate the new technology of the VR, virtual reality system, and we want to test that in the real world. But at the same time, because we are psychology researchers, we care about research ethics. We do not want to put our drivers on the road and facing potential danger. And in psychology, there is a term that is called pilot testing. Does everyone know what pilot testing is? Pilot testing is not testing the pilot. It's testing the new system. So I guess that's probably the reason the system is called autopilot. So basically, the owners of the new technology is helping the company to pilot test the system. But many of them do not know they are being pilot tested. Sorry, I might sound a little mean, huh? Okay. But I have serious concern about consumers and owners are not well informed about the limitations of the system. And I think it's the responsibility of researchers to educate them, to inform them. So I think to test the new technology in a closed course should be the first step instead of put them on the public road. And again, for the autonomous driving, and yeah, driving research has existed for more than 50 years. And again, thanks to the new technology of semi-automation, and that put a lot of job security for us. So we can still secure our job for the next 50 years, I guess. So surrounding the autonomous driving, we have so much to study and a lot of open areas, a lot of open questions for us to study systematically, either qualitatively or quantitatively. Okay, thank you, everyone. Sorry, I forgot this last slide. There's so many open questions, but at the same time, there's a great deal of challenges facing us. So first, how can we get the data from the car manufacturers, the data sharing, so that we, as a researcher, we can really have the first-hand information and the data to study, okay? And what could be the commonly accepted testing platform? And different terms, could they be unified? And of course, we need the support from the car manufacturers. I'm not criticizing them. I'm urging them to share the information with us so that we can test and present and publish data and share with the public. And of course, government support, insurance company, or a nonprofit foundation like AAA. And engineering researchers, and of course, human factors researchers as well. Okay, thank you. Now this is the end.
Thank you, Ray. Appreciate it so much. More great information. It's hard to believe that there are that many accidents here in Wichita, as Ray told us about when he first started his presentation. It just doesn't seem possible, but I have seen so many accidents. I've only moved back 2 months ago from Houston, and I'm trying to figure out how can Wichita have maybe almost as many accidents as a town like Houston? And it just seems so strange. So I think a lot of people are not paying attention, as we've been talking about this morning. And I also have to agree with Ray with teaching the teenage drivers how to drive. I have one too that I'm getting ready to start teaching, and I am scared to death. And I just wonder how they are going to react to all this new technology with driving. I can just see them on the road not doing anything but on the phone and watching Netflix and stuff like that. So it's going to be interesting to see how the next generation reacts to all this new technology with driving. Okay, moving on. Our next presenter is Amanda Graor, the Chief Innovation Officer at the Mid-America Regional Council, or MARC as it's called, in Kansas City. She has been with MARC for more than 11 years with work areas focusing on air quality, workforce transportation, energy policy, and climate strategy. In her role as CIO, she's responsible for increasing MARC's capacity to advance regional goals and collaborative initiatives through innovation in public policy and operating practices through strategic deploying of data and technology. Please join me in welcoming Amanda Graor. Thank you. Yeah.
And now for something completely different. I am not a PhD researcher, and what my research background focuses on, my master's is in public administration, and what we do at MARC. How many of you have heard of the Mid-America Regional Council? So we've got a couple, okay, great. I've got a former coworker in the audience who's now with NHTSA, so I didn't expect to see him today. So the Mid-America Regional Council is the Regional Metropolitan Planning Organization, or MPO, for the Kansas City region. We do transportation planning in 9 counties, 2 states. We've got 5 counties in Missouri and 4 counties in Kansas. Every metropolitan area in the country over about 50,000 people has one of these organizations. So in Wichita, it's WAMPO, it's the Wichita Area MPO, but there's one in the Flint Hills, there's one in Joplin, there's one in Springfield, there's one in Jefferson City has its own, it's based on population. But we are the ones required to do transportation planning for a metropolitan area. I have nothing specific to say about the current state of autonomous vehicle technology and my level of trust in it or research on it, but what I will say is that we are required to do transportation planning on a time horizon of 30 years. We cannot wait to see where technology is going to make decisions on transportation infrastructure. If you think about the amount of funding and investment that local governments, states, the federal government make in their transportation infrastructure, they're making these decisions 5, 10, 15, 20 years out, and the investment that you make has to last 50 years. These are 50-year investments that we're making. And so what I'm here to talk about today is the human factor and human mobility and the impacts, but from a regional transportation infrastructure planning perspective, where the wait and see approach isn't necessarily going to work for transportation infrastructure. This is from a National League of Cities report that came out in the last couple years, and just talking about how the development of autonomous vehicle technology, I love a good pun, has recently shifted into overdrive, right? Like, this is something that we can't really ignore. It's happening around us, and the wait and see approach as it relates to investment in transportation infrastructure, we have to make these decisions now that will impact not just 10 years from now, but future generations of the traveling public. So I mentioned Mark as the regional MPO for Kansas City. We are also the Regional Council of Governments, which means something a little bit different in that we also coordinate our regional area agency on aging. We coordinate Head Start and early learning programs. We coordinate the regional 911 system. We coordinated our regional Homeland Security funding. We coordinate research services, economic forecasting, land use forecasting. We do public health and SNAP benefits. There's all kinds of things under the umbrella of MARC. And so this also makes it a really interesting place to do this kind of regional planning, because we have all of these emergency services and public safety and workforce transportation and aging and school transportation and all of these different things under the same roof. So when we started developing our autonomous vehicle policy framework, we started in 2017, we had different, basically subject matter experts leading our work in these different areas. This is from a report, Driverless Future Policy Roadmap for City Leaders. Basically, cities that do nothing face major risks. We don't have the option of sitting and waiting and seeing what the case is with the technology in 15 years and waiting for it to be fully ready to come to market. There are a lot of areas in the country where I personally have ridden autonomous shuttles in 3 different states in the past 2 years. People are pilot testing these all over the place. There's different cities, particularly Arizona has a big culture of testing. That's where the Uber crash happened that was mentioned in a previous presentation. But the city of Pittsburgh, the city of Boston, Tampa has done it, the state of Florida in general has done a lot of connected and autonomous vehicle pilots. These are happening all over the country. This is not something that's super futuristic. There's conversations going on. I went to the University of Michigan for undergrad. I have an engineering degree from Michigan, and the autonomous shuttle pilot that's going on the University of Michigan's campus has been running all semester. I mean, these vehicles are on the road now. It's not a super futuristic thing to talk about how we deal with and make policies for these types of vehicles and technologies. So we were looking at all these technology trends as a region, and this is a national technology trend overview, looking at the increased widespread data and connectivity, not just for transportation, but this is just in general. The advanced vehicle technologies, we've mentioned a lot of them this morning. The adoption of new technology-enabled mobility options, so I'm talking about Uber and Lyft and these app-driven, call a vehicle, but it's through a technology that you have to interact with before the ride comes. Developments in technologies affecting freight movement and logistics. The economy in Kansas City, a huge portion of it is freight and logistics related. We're the 2nd biggest rail hub outside Chicago. We have significant freight and logistics going on, not just in goods movement itself, but also in jobs. A significant number of jobs in the region depend on the freight and logistics market. And just advances in transportation system management and operations. I mean, you see those signs going down the highway that tell you there's an accident ahead or how many minutes until you reach the next highway, and that's a dynamic message board based on the current conditions. Those types of advances in system management and operations that try to keep the impacts of any individual incident at a minimum or help reroute drivers. I don't know how many of you noticed if you use Waze or Google Maps, it will dynamically reroute you around a crash, even if you've already put in your navigation, you put in where you're going, you could be halfway there and it'll tell you there's an incident up ahead, would you like to reroute on this other route? Those types of advancements that are already deployed, people are already taking advantage of, these are the types of things that we have to think about when we're planning transportation infrastructure. USDOT came out with guidance. They've come out with a couple of rounds of it now, but in the first round of guidance, NHTSA encouraged, the emphasis is mine, but encouraged collaboration and communication between federal, state, and local governments and the private sector. As technology evolves, and the agency will continue to coordinate dialogue among all the stakeholders. There have been a lot of listening sessions around the country on autonomous vehicles, but collaboration is essential between those state, federal, local partners. I don't know how many of you are familiar with how transportation funding works, but your state and local and federal partners are in pretty much constant conversation about how investment works, how federal dollars are being spent, what local dollars are going toward it, what the state is putting in. It's intertwined in this way that there aren't very many projects that don't have multiple types of funding that get put on them. So when we started talking about it on the regional level, I mentioned Kansas City is a bi-state region. So there's a potential to pass back and forth across not just county and city boundaries, but state lines constantly. I started my drive this morning in Missouri. I crossed the state line just to get here this morning. So if we have 2 state legislatures and 2 governors and 2 approaches at the state DOT level on autonomous vehicles, it impacts the Kansas City region significantly because the state line goes right up and down the middle of our region. Our population is pretty balanced on each side of the state line. So we started asking these questions that had regional importance. We were wondering how these technologies will impact our existing work. Like I mentioned, some of these decisions that we're making are years and years in advance. So sometimes we made a decision on a specific transportation investment 5 years ago, and that's a long time in the lifetime of technology. 5 years is a really long time. But 5 years ago, they didn't know where we'd be now. And so how will these technologies, as they emerge, impact the work that we're already doing? What regional goals can be met or addressed through the deployment of new transportation technologies? We have a lot of regional goals, and most of them are human-focused. Reducing roadway fatalities, making the transportation system safer for all users, making the region a great place to live, work, and play for all residents. How can we meet or further address goals that we already have through technology? Technology in and of itself is not the goal. Technology is a tool to meet a goal. And so what can we add to the toolbox, add to our pantry of options to meet our existing human-focused goals that we already have as a region? What capacities need to be developed for successful deployment? I mean, we've got a lot of people in the workforce who went through school 30 years ago, and they've got 30 years left to go. And what they learned in school, as far as technology is concerned, is not all that relevant anymore. How do we reskill, upskill our employees now, for not just for people to change careers entirely, but to maintain the career that they have now and really interact with the people coming out of school, with the research that's going on, and get people up to a level where we don't need to have an entire fleet of data scientists and an entire set of computer engineers everywhere. But in order to be able to understand the big conversations about data and technology, there has to be ongoing training in a way that really doesn't exist at the moment. What local and state policies need to be developed or amended? One of the big ones, frankly, autonomous vehicles are not allowed to operate on public roadways. In Kansas, I was on the statewide AV task force for the state of Kansas over the last couple of years. One of the conversations we had is, well, maybe we could do some testing on truck platooning because as long as there was a driver in the seat, that met the current regulations and you could still do some testing with autonomous technologies. There's other states, like the state of Tennessee had to change their state legislation because it requires both a driver in the seat and hands on the wheel for it to be legally operating on a public roadway. So looking at those kinds of state regulations that didn't anticipate autonomous vehicles, they didn't anticipate this type of technology, what do we need to go back and change, or what do we need to have a new policy about altogether based on new transportation technologies? And what are the priority opportunities for pilot projects and targeted investments? This isn't something we can roll out all at once. Connected vehicles or incident management systems, they're expensive. This isn't something we can put on every single roadway right away. So what are our targeted opportunities? Is it high crash areas? Is it areas that have heavy congestion on a regular basis? And how do we make the most of those early investments so as it rolls out, we get the data, we get the experience that we need to make it a system-wide improvement, but being very deliberate with those early investments. So we looked at 7 different areas as we were developing our autonomous vehicle framework. We looked at infrastructure planning and investment. We looked at data management, which originally was data management and cybersecurity. And as we got into it, it was basically determined there's not a huge local role in cybersecurity, right? The OEMs decide that stuff, the market decides a lot of the cybersecurity rules and protocols. So staying up on it was important, but as far as a local role was concerned, we focused mostly on the data management and less on the cybersecurity piece. It's still a very important piece to it, but we felt like it was something that we needed to pay attention to and implement, but not create regionally. Environment and land use, travel demand management and system performance, economic and workforce opportunity, equitable access and mobility services, and certification, liability, and insurance. We had a working group, so we had an overarching steering committee that was a combination of public and private and academic, and our local government partners and our state government partners. We had a working group for each one of these areas that nailed it down even more specifically with subject matter expertise in each one of these areas. So I'm going to touch on two of them this morning. Specifically, the Equitable Access and Mobility Services Group was looking at the consideration and mitigation of digital divide and access to services and opportunities for shared mobility services. So I talked about the technology-enabled transportation. If you need an app and a smartphone and a data plan and a credit card just to access a transportation service, how accessible is that service really to the entire population of a region? What if your battery dies? What if you have all of those things, but your phone dies? Do you no longer have access to the transit system? Do you no longer have access to a fleet of vehicles? Thinking about these things and making sure that there are publicly available ways to access transportation. We've got a series of kiosks in downtown Kansas City that are Wi-Fi enabled, that you can find the bus routes and you can buy passes and things like that through them. Making sure that we don't rely on each individual person to maintain this whole suite of services individually, so they don't lose access to the system if just something goes wrong with one of those pieces. So the Equitable Access and Mobility Services Working Group, these are some of the recommendations that came out of that group specifically, talking about the app or technology-based solutions, and that honestly may make the transportation system less accessible to those with transportation disadvantages. If you're already having a hard time paying for the bus and you don't have a personal vehicle, and then all of a sudden we make bus passes only available on a smartphone. So I know we talk, there's a conversation about public Wi-Fi, and people think that public Wi-Fi is a luxury. Like, why do people need internet access everywhere? They've got data plans. Not everybody has a data plan. And a lot of people have data plans that are limited by the number of megabytes that they can use in a month or things like that. Thinking about the data it takes to buy a bus pass and use a bus pass or to access transportation, that may be data that they no longer have to use to access a job application or to access homework if they're taking classes. So thinking about just the whole environment of how people use services and how they interact with them is really important when we talk about transportation. Transportation is a basic need. You have to get to work, you have to get to school, you have to get to healthcare, and if some of these things are actually making it less accessible, then that's not really, there's a saying that one of my professors when I was working on my master's, efficient and effective for whom? You create a service and you say it's effective and you say it's efficient, but you have to define efficient and effective for whom. Talking about the percentage of the population that will refuse to adopt new technologies, regardless of the potential impact on them or others. You'll never get 100% adoption on these things, so how do you make sure that they still have access to participate in the transportation system? The level of human interaction, whether it's social needs or level of service needs, so we're talking about door-to-door versus curb-to-curb service. So you have medical transportation, things like that. Some people can get themselves out to the curb, and they could take an autonomous shuttle because they don't need a driver, but some people need door-to-door service. They need someone to physically help them get to the vehicle. So what does that look like? But also, how can we right-size those types of services so we aren't requiring a door-to-door capability for people who only need curb-to-curb service? How can we actually expand the capacity of those types of services so everyone's being served in a meaningful way at a lower cost because they're not actually overusing a service that they don't actually need? The potential to move users to more appropriate levels of service to increase access, what I was just talking about, and the great potential to provide higher levels of mobility to transportation disadvantaged populations if implemented thoughtfully and equitably. Those are all of the things we were already just talking about. We have to think about this and make sure it's a meaningful implementation, not just for certain portions of the population, but that we're addressing the needs of as much of the population as we possibly can with every decision. Another area of analysis was environment and land use, and this is where we're starting to make those decisions about current land use and current built infrastructure, but how these changes can use the existing built infrastructure more effectively with a forward-looking view on autonomous vehicles. So how might the AV goals or impact existing goals related to quality places, related to centers and corridors planning, density, mixed-use development? How can we talk about shared versus individual ownership? Will you even own a personal vehicle going forward, or you buy into a fleet similar to a zip car model where you just pay a fee, a monthly fee, and you access whatever vehicle's available instead of having one sitting in your driveway 95% of the time? Most vehicles are not in use 90% of the time. The reclamation of land from the transportation system, if we really can't increase highway capacity, if cars can travel closer together because they're connected to one another and they're seeing each other and they can safely travel closer together, do we actually need to build more lanes of highway, or can we actually use the existing capacity of our highway system? The big one that was talked about a lot was the changes to the operations of the existing infrastructure, such as pickup and drop-off areas. So take 3 curb spaces off, 3 parking spaces off the curb, make it a pickup and drop-off area, and that more safely allows for things like Uber and Lyft to operate now, public transit, having designated curb space to use for that activity. But then as we talk about autonomous vehicles, that they can also use that curb space in the future, but there are current day applications for that type of thing now. I don't know how many of you have dealt with this. I live in downtown Kansas City, and on a regular basis, I am stopped behind an Uber who decides to just stop in the middle of the road and let their passengers out right there, you know, blocking traffic, or pick someone up in the same way because they don't really know where they are. The pickup is right on a corner of a super busy intersection, and that driver just stops and lets their passenger get in, and you're just waiting behind them. So if you create designated areas for that type of activity, not only does that not impede the flow of users on the roadway, but that's also setting you up for future operations management that can assist with the autonomous vehicles going forward. The primary recommendations that came out of all 7 of those working groups were an ongoing need for regional stakeholder education. Basically, we don't know enough. We need to keep learning and keep up with the current technology trends and the land use trends to make sure that we're making good decisions, like I said, for 20, 30 years in the future. A big emphasis on those land use policies, figuring out how to deal with current parking needs, current curb sharing, the pickup and drop off areas. What can we implement now that will be useful now, but also in the future? And then talking about pricing strategies, there's a significant, in the development of autonomous vehicles, most of them seem like they're going to be electric. We already have declining revenues from fuel taxes and things like that. How do we talk about pricing models differently? It's going to be turned on its head anyway at some point as cars get more efficient. We already have a much higher need for infrastructure investment than we have the ability to pay for. So how do we start talking about pricing transportation differently? Regional and multi-jurisdictional data sharing. Transportation is a system. Like I said, we pass jurisdictional boundaries all the time. So if everything is focused inside a city and just at the city level of operations, there's all these edge cases as you pass to different jurisdictions that if nobody's sharing data, you don't actually get a good sense for how the entire system is operating. And then that equitable access to services in the transportation system. That has to be at the forefront of all of the decisions that we're making to make sure we're not actually decreasing the ability to participate in the economy and in the region for people who don't have access to technology, to credit cards, to things like that. The overarching theme of all of the working groups was that education piece, things like this, other educational opportunities that are in a slightly more informal way so people aren't having to take certificate classes and engage at levels that they're not really interested in, and that keeps them from knowing the information that's not presented on local or network news. Being able to talk about these things at a meaningful level, at a regional level, at a local level, so they understand what impacts are happening and what these decisions mean for their own city and for their own state, instead of just sort of the national trend conversation. There's a whole bunch of other stuff in the white paper and the plan that I was mentioning. If you want to find it, you can go to mark.org. I sort of have a roadmap to get there because our website's not exactly the most user-friendly at all times. So if you go to regional planning and then find the innovation tab, and it's under the autonomous and connected vehicle framework. Thank you for your time this morning. If you have questions, we'll have them at the panel at the end. Thanks.
Thank you, Amanda. Appreciate it so much. All right, guys, we're moving on. Great information from Amanda. There's so many questions to be answered. Some of these things you don't even think about, like equitable access, like who can get, everything right now is turned into technology. Even with news, we always tell everybody go to our webpage or get our app, and we forget to think that not everybody has access to that sort of thing. So that's some really good information to think about. Alrighty, our final presenter today is Director of Wichita Transit, Mike Tan. Mike has 40 years of transportation industry experience, from private industry trucking and warehousing to logistics, and the last 13 years in public transportation. He believes strongly in the value of good public transit that provides multi-modal opportunities for education, employment, and economic expansion. He has implemented alternate fuels in both of his fleets and has managed including converting some buses here in Wichita to electric battery power. He has led strategic partnerships with USD 259 and Wichita State University, both of which have increasing ridership and have grown mobility options for students and the entire community. Please welcome Mike Tan.
Thank you, Felicia. I got to tell you a couple things. People talking about the weather today. Where I came from, which is up near Buffalo, New York, we get over 100 inches of snow, and 3 months out of the year it's below zero. So actually, this is balmy for me. I don't wear jackets to work and all that kind of stuff. So it is, when I hear it here, it's different. So we really love the weather here in Wichita. The other thing was, I noticed everybody else got 25 minutes. I got 5. So I'm feeling like the Rodney Dangerfield of our group here, but my staff will tell you that there's probably nothing I do that takes 5 minutes. So yeah, I don't think it's going to be 5 minutes, but I'll try to make it as fast as I can, that's for sure. I'm going to talk a little bit about the type of automation that is coming down the pipe in other cities, other countries, with regards to autonomous public transit type of applications. But I did want to start out with this screen, because that bus right there will be on the streets of Wichita in about a month and a half. So we have 4 buses identical to that that'll be delivered, and then we have a total of 7 more buses that are electric powered that are be coming in the first quarter. So by the end of the first quarter of 2020, you will see those buses on the street of Wichita. And quite frankly, the city of Wichita will no longer be purchasing diesel buses. Our plan is to continue to, as we replace our buses, replace them with only electrics, and then also make them more size applicable and technology applicable to what the future may be. So we're very excited from that standpoint. That bus and all of our buses now are connected via Wi-Fi for our passengers on our buses. All our facilities are Wi-Fi connected and available for public Wi-Fi for our people to use them. Some of the things that Amanda mentioned, people that are on our bus can use their Wi-Fi in all of our buildings for any of the products that we have. Those buses connect through data. They connect through cell. There's multiple cameras on those buses. There's brains all over there, and it is a very technologically advanced vehicle. So we're very excited about the direction that we're going, and we're hoping that we're creating the ability to be flexible on things that are coming down the pipe. Because right now we struggle with a number of different things